Today we're going to go over CC1 7.3.1 review and preview. We are going to start with problem number 86. Recall that an inverse operation undoes each other. Okay, if I have an inverse operation, it undoes the other operation. Write the inverse operation for each situation below. So how do I undo adding 3/4? Well, I subtract 3/4. If I subtract 1 2/3 to undo it, I add 1 2/3. If I divide by 8 to undo it, I multiply by 8. And if I multiply by 12 to undo it, I divide by 12. Okay, problem 87, we have another magic trick. So look carefully at the algebra tiles to fill in each of the steps. Use your own numbers in the trials, again considering fractions, decimals, and zero. Okay, I do have to fill in the spaces, so I have my pick a number already done. I add 3, and then I ended up with 3 sets of it, which means that I multiplied by 3. I took these away, so I subtracted 3. I went from 3 groups to 1 group, which means that I divided by 3. And then my last step is to subtract the original number. I'm not going to go through each trial with you. You're going to select 3 numbers to try. Remember, fractions, decimals, and zero are always good options to try to see if you get a different number. However, if you're going to check your work, look at this picture here. The number you should end up with matches this picture. Okay, moving on to problem number 88. On graph paper, draw a rectangle with the width of 5 units and a length of 7 units. Okay, width and length. So 1, 2, 3, 4, 5. Length of 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's my rectangle. Draw a new rectangle that is an enlarged copy of your original rectangle, and the length is 13 units. So up and down, it's going to be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Problem. I don't know what my width is supposed to be. Because my length got bigger, I can assume my width got bigger, but I need an accurate enlargement. So part B says show how you can calculate the width of your new rectangle. I've started it here. I have my width and my length. So I want to take my width, which is 5, and my length, which is 7. I want to compare it. Okay, I made an equivalent fraction with my new one, but I don't know my width. I do know my length. Well, I have to figure out what did I multiply by 7 to get to 13? Okay, now a good way to do this is to say, okay, well, if I work backwards, 13 divided by 7 is going to get me my answer. Now the problem, if I do a calculator, 13 divided by 7. Get that number. Okay, now I'm going to write it down. And the reason I'm writing it down is just to show you that it is a larger number. Okay, so I have 1 and 8, 5, 7, 1, 4, 2, 8, 6. Okay, this number I have to multiply by the top, just like I did the bottom. Okay, it's that giant 1. I have to do it. So I'm going to keep that number in my calculator. I'm going to say, well, I had to multiply it by 5 too. Look at that, I get a number. Okay. So 5 times that number is 928571429. That's a pretty big number. I don't know how to graph that here. So what I'm going to do is I'm going to take the number in the 10th spot. I'm going to round to the nearest 10th. So I'm going to look at the 8. It tells me, well, that 2 needs to go up. So it's 19 3/10 is what I'm going to round it up to. Or 9 3/10. Sorry, not 19. 9 3/10. That is much more easy for me to graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 3/10 is somewhere partially in there. It's not going to be exact when I put it on my graph, but that is why we label. Okay, so make sure that your labels are there. Okay, problem 89. Kate has 5 sandwiches. And she's sharing it with 3 friends. So each person gets an equal amount. So she's dividing it by 3 friends. This is the same thing as saying 5 divided by 3. Okay, now I could get a decimal and whatever, but I can also put it back in fraction form and say, okay, what's my mixed number? 3 goes into 5 one time with 2 left over. So it's 1 2/3 sandwiches. That is what everybody gets. I spelled sandwiches wrong, so there's no H. Okay. My answer is 1 2/3 sandwiches. Okay. Last problem, number 90. Find the area and perimeter of each figure below. I have a parallelogram and a trapezoid. As a reminder, my area formula for a parallelogram is base times height. For a trapezoid, it is add my bases times my height, divide the whole thing by 2. So I'm going to start with my parallelogram for my area. My base, 20 2/10. My height is not 14, it's 12 because it's going straight up and down. It's perpendicular to my base. Now I'm going to use long division here just to practice my skills. You should be too. It's good skill to practice. 2 times 2 is 4. 2 times 0, 2 times 2. Move my place value over. 1 times 2 is 2. 1 times 0 is 0. 1 times 2 is 2. And I add, I have 4 plus 0, 2 plus 0, 4 plus 0, and 2 plus nothing. I move my decimal 1 place in, get 242 4/10 centimeters squared for my area. For my perimeter, I'm going to add all the outside edges. So I have 14, this is also 14, and this is 20 2/10. I do not worry about the 12 in the middle because that's not on the outside of my shape. So I have 14 plus 14 plus 20 2/10 plus 20 2/10. I line up my decimals. I can fill in spots. 0 plus 0 plus 2 plus 2 is 4. Carry down my decimal. 4 plus 4 is 8. 1, 2, 3, 4, 5, 6. My perimeter is 68 4/10 centimeters. My trapezoid. Okay, base 1 can be 7. So I'm going to do this down here. So I have 7 plus 17 8/10. That's my base 2. Times my height. My height is not 6. It is not 7.5. It is 4. Divide the whole thing by 2. 7 plus 17 19 and 8/10 is 24 and 8/10 times 4 divided by 2. 24 and 8/10 times 4 is 99 and 2/10 divided by 2 equals 49 and 6/10. That is my area, meters squared. My perimeter, I'm going to take all of my outside pieces and add them together. So I'm going to start up here. I have 17 and 8/10, 6 and 0/10, 7 and 0/10, and 7 and 5/10. Remember, I can put in place value holders. 8 plus 5 is 13. 7, I have 3 sevens. 7 times 3 is 21. Plus 1 is 22. Plus 6, 22 plus 6 is 28. 2 plus 1 is 3. My perimeter is 38 and 3/10 meters. As always, if you have any questions, please make sure you come and ask.